Brilliant. Thank you, everyone. I will do my best to do my part here. A few sort of notes before I launch into it. So this paper is called "Who Drives Digital Innovation? Evidence from the U.S. Medical Device Industry." For those of you who've known me for the last 10 years, you'll know that I've been at HBS. I'm in the process, you were catching me during the last few weeks of having 2 affiliations. I'm in the process of moving to the Hasso-Plattner Institute, which is also my apology to my patient discussion, Iain, who not only received a paper late, but not fully baked. So thank you, Iain, again for being patient with me. And also a brief advertisement, which is that I will be hiring postdocs who do stuff at the intersection of innovation and healthcare over the coming months and years. So if you are or know of wonderful people who want to do things related to healthcare and innovation, digitization in particular, drop me a line. So with that, I'm only gonna, as everyone knows, I do innovation, but really only in the healthcare setting. And I want to give you a quote from this great book by Bob Wachter called The Digital Doctor. This is his vision of the future of healthcare. The heart failure patient will have his state of hydration and vital signs monitored through sensors embedded in a watch, a wristband, or a stick-on device. The diabetic or the kidney failure patient who needs periodic blood monitoring will be able to prick a finger at home, assuming that test still even requires a drop of blood. Many of today's tests will be replaced by sophisticated sensors. The specimen will be processed in seconds through a smartphone attachment, and the result will automatically be entered into the electronic record. So this is sort of the vision. Anyone who's actually interacted with the healthcare system on either side of the Atlantic recently is well aware that we're still quite far away from that. Nevertheless, we are really seeing the rise of a set of both novel and not so novel, I'll talk about that in a bit later, digital devices in healthcare. So this thing on the left is in fact such a stick-on sensor that can measure things like blood sugar levels through sweat. This is, of course, a digital insulin pump right here that a diabetic patient might wear. And who knows what the thing on the right is? You can see for scale, it's the size of a dime. It's not in the ear. It's a good guess, because ear devices are quite small. It is a CardioMEMS device. It's an implantable heart failure monitor. So this device is actually implanted in the patient's aorta. It measures blood pressure within the heart. There's a precipitous change in blood pressure up to 24 hours before a cardiac event happens for a patient with heart failure. And so if you have one of these devices, you can actually remotely monitor a patient. The research that has come out since we started this project is increasingly positive about this device. It is cost effective, it saves lives. You can actually prevent major cardiac events and statistically deaths by giving patients these things. So quite exciting. What these things have in common is that they're all regulated medical devices, and that's what I'll be talking about. Some quick definitions, less necessary for this audience. So when we talk about digitization, or in Europe with the extra syllable, digitalization, we're really just thinking about things that generate digital data or allow us to visualize things digitally. Digital transformation, however, many of you think about, is really about these industry-level changes that come about as a result of digitization or digitalization. And so what I'm going to do in this project is take advantage of digital data from the regulatory documents describing newly approved medical devices, in fact, basically all of them, to characterize the digital transformation of the medical device industry. With a brief disclaimer, this is still work in progress, and it's super micro. So relative to some of the papers we've seen recently, this is sort of really, it's just going to be the micro data. So if you're here for that, great. If not, then I'll be able to see if you're sleeping, but feel free to check out. In terms of sort of how to think about this paper, I will say that that in terms of the sort of flavor of the research I'm about to talk about, it's most similar to the work that you already saw from my HBS colleagues, Karim and Shane, sort of thinking about both characterizing digitization through like a bunch of descriptive statistics, as Karim did, and then I think there are many similarities with Shane's wonderful presentation from earlier this morning. So Shane, I at least expect some sort of comment from you afterwards. So how much digitization are we talking? So these are the questions that I'm hoping to answer, at least in part today for you. How much digitization are we talking about here? Who are the actors? Who are the firms actually doing this? I'll spend less time on that today. What types of resources seem to be most important for digital innovation in this setting? And then does technological innovation seem to be enabling the rise of new entrants or reinforcing incumbent advantages? This is an age-old question, but we don't talk about this much in the regulated setting, and digital transformation is a cool way to think about that. So. So software-driven innovation in healthcare. Previous studies have highlighted the importance of software and digitization in determining both firm innovation and performance outside of healthcare. Many of you know and have written these papers. Here we have this opportunity, and I think what I like about studying the medical device industry, in addition to knowing the data and the setting quite well, is this is an opportunity really to observe the wholesale digital transformation of an industry through microdata. And the reason is it is literally illegal to market medical devices without regulatory approval. So if you have, and all the regulatory data is public, so if you have all the regulatory approval data, you can necessarily see the universe of products that ever came to market. In general, that said, we know very little about the impacts of software and digitization in healthcare. There are a few notable exceptions, studies of electronic health records, studies of things like genetic privacy laws, but otherwise we actually don't have tons of empirical research at the intersection of sort of healthcare and innovation, thinking about digitization. In recent years, there's been, of course, massive growth in the number of connected devices, fitness trackers, medical equipment, and the medical device industry itself is a $170 billion per year industry in the United States alone. It's about double that worldwide, so it's of consequence. So what am I going to show you? Dietmar's going to keep me on time, so if I run out of time, then at least you'll know where this all ends up so far. We're going to use text analysis very much in the spirit of what Karim and his colleagues did, perhaps a bit less sophisticated, to characterize over 30,000 new medical device product summaries. We're going to document substantial digital innovation in medical technology with pretty clear heterogeneity across different medical specialty areas. It won't surprise you, but it's nice to have these data. I should just mention, if you ask the US FDA, how many digital medical devices did you approve last year? They would not be able to tell you, because that's not something that's tracked in the regulatory data. So you need people like me who are fascinated by regulatory data sets, by innovation, to actually go scrape product summaries and tell people like you about it. But we're also doing some work communicating this to medical audiences, of course. We're going to examine the relative importance of measures that will seem very familiar, things like within firm experience, financial resources. Do you have VC funding? How much VC funding do you have? And geography in predicting new digital product development. We're going to find that different types of products or different types of firms are going to be contributing to digital new product development differently. In terms of really novel innovation, and this kind of has flavors of Shane's presentation earlier, both publicly traded firms and those with venture capital at all and greater amounts of venture capital are going to be more likely to commercialize truly novel digital devices. These are products in categories that did not exist until a digital product came to market. But access to capital, or these measures of access to capital, I should say, seems to play very little role in predicting the digitization of analog product lines. And what I mean by that is like slapping a digital monitor onto a blood pressure cuff. We've been measuring blood pressure with regulated medical devices for decades and decades. Actually, since before our current medical device regulations existed in the United States, we've been able to measure blood pressure with blood pressure cuffs. Now they're all digital. That is digitization, but that's not really innovation in the sense like we could measure blood pressure before. And so these measures of access to capital don't predict basically the digitization of existing analog products or developing follow-on innovations. What does is these different measures of experience. So these are things like if you have experience developing clinically similar products, if you've developed a lot of cardiovascular products, you are going to be marginally more likely to develop follow-on digital devices in the cardiovascular space. Both clinical experience as well as software experience predict the development of these follow-on digital products, and in contrast, we actually don't find that any form of this experience, whether it's experience with regulated products, experience with a specific medical specialty area, or experience with digital products, none of those things predict who develops truly novel digital products. So these measures of experience tell us sort of who does various flavors of follow-on innovation. As such, we so far have concluded that the digital transformation of the medical device industry has afforded new and distinct opportunities for industry incumbents versus new entrants. And that sort of slices differently, of course, depending on how you think about things like venture capital. So medical devices, super quick. This is a heterogeneous category of medical products that you don't ingest or inject. These can be analog, so these can be things like a simple catheter, or they can be relatively complex, things like a drug-eluting coronary artery stent, or they can be digital, they can be insulin pumps or implantable heart failure monitors, which you learned about earlier. What I'm going to do is consider all of the devices that are subject to an FDA regulatory approval process. This will include all of the high risk and moderate risk products out there. As a quick reminder, this will include the first two categories. So this is class 3 devices. These are devices of very high risk. These are implantable and or life-sustaining. If something goes wrong, it will go horribly wrong and could cause permanent damage or kill you. Moderate risk devices, you don't want anything to go wrong. It could cause damage, but it's unlikely to kill someone, is basically the rule of thumb. These are things like blood pressure monitors, hearing aids. By the way, just about every diagnostic or treatment algorithm, I have some extra work, separate work on artificial intelligence and regulated medical devices. I'll show you one picture from that later. Just about all of the AI products that the FDA regulates are in this category. So just in case anyone's wondering. What I won't tell you about are the lowest risk medical devices. These are not subject to a formal regulatory clearance process. These are things like latex examination, gloves, stethoscopes, tampons, condoms. These are things we want to be manufactured in a clean and certified facility, but we're not going to actually regulate the product itself because it's so low risk. Okay, we're going to have 3 data sets. We have regulators' administrative data from the FDA, 2 recent decades of medical device approvals. Something we're working on right at this moment is getting another 2 years of data, which I had hoped to have for this week and don't, but it's coming. Unstructured text data describing all of these devices. So we're going to actually scrape product summaries. I'll show you a screenshot, I think, on the next slide. And then we're going to match this with firm-level financial data at and leading up to the time of medical device commercialization from various sources that you're probably familiar with, as well as data about VC financing. And then we're going to account for acquisitions through a process that you don't want to know how the sausage is made, but it took 2 months to get right. But basically that the firm that is responsible for bringing a device to market is given credit for that commercialization. And then we're going to pull some additional geographic data on things like expertise and experience using firms' own histories of product commercialization from the FDA, as well as measures of like how many software engineers do you have in your state to figure out if that's a friction or predictive here. And we're going to be able to consider about 30,000 new devices. So this text database, I'll show you the screenshot now on the next slide. So what is this? So it's part of the application for clearance or marketing that's sent to the FDA at the time of product approval. It's published online the day after a new device is cleared or approved for marketing. It's in a standardized format. 98% of these documents are machine readable with off-the-shelf optical character recognition software. And there are no sort of funny concerns you should have about that 2%. There's no concentration over time or in medical specialties. It seems to just be sometimes things were randomly scanned in at a diagonal. One of the other things that we're doing in this data update is using better OCR software, and that number will go up. Don't worry about that piece. We're going to end up with 30,000 computer-readable text documents, and we're going to do some text analysis. Now it's really the next slide. Method 1 is actually, I'll give credit to Dan Gross, who told us about the National Library of Medicine's mesh descriptors. We're going to do what Dan did. It's an off-the-shelf algorithm. It's used all the time, it's rigorous, it's third party, but it's not transparent, so you can't actually see the algorithm itself. You just get the output of the algorithm when you send the text files to the National Library of Medicine, so we don't really know what's in there. The simplest thing that's super transparent but homegrown is this supervised document classification that we do, where we basically focus on keywords from a glossary of computer terminology, and this looks quite a bit like what Karim and his colleagues did. We're going to scan for keywords that are unambiguously associated with software and or product digitization, words like software and computer. The nice feature of this, we had RAs check nearly 200 of these, I think it was 180. These words are only used if the functionality of the device actually involves these things. So there's no reason, like you wouldn't write in one of these product summaries, oh, by the way, this hip replacement device does not include any software. Like that, there's no reason to mention software if there is no software. We found in the 180 that we looked at, we found a 0% rate of false positives. So, you do with that what you will, and we're going to focus on multiple terms. It turns out just looking for the word software actually does the trick. So this is the screenshot I promised. We're going to have a summary of safety and effectiveness data for this device. This is a Medtronic continuous glucose monitor. What you can see is just there's a whole section about software. This thing is clearly a digital product, and it talks about its software a lot. I don't want to bore you with the tables, but we're basically going to have the sample that you expect I have. We have these different flavors. I just want to take a moment to tell you about these different flavors of new devices. So there's a new digital product code. That's what we think of as novel innovation. This is a product that a product type that at its inception was digital. These product codes you can think of as things like basically product categories. These are things that are excellent substitutes for one another. These are things like there's a product code for drug-eluting stents. There's a product code for pacemakers. So these are things, they're not perfect substitutes, but they're basically excellent substitutes for one another. And then there are various ways in which you can do follow-on innovation. You can take something that's historically been around for a while, that's been analog, you can put a digital display on it. That's the first digital product code in the first digital product in an existing product code. You can have a follow-on digital product, and then you can have a digital product update, which is a firm that already has a digital version of a product in a product code comes up with another one. So that's just like a product line update. That's not even, that's innovation in some sense, but not novel innovation. Okay, I'm going to go through this quickly just in the interest of time. I'll show you some pictures. This is easier to digest than tables. So you can see the share of newly approved digital devices is growing over time. This isn't asymptoting. This isn't doing what Karim's pictures did, what AI does also in this setting, but this is sort of digitization. Lots of heterogeneity. That top line is radiology. We're now at a point where like 96% of all radiology devices that come to market have or interact with software. We can look at the cumulative number of product types that have been digitized. That's going up over time. We can look at the cumulative number of firms doing this. That's going up over time. We can look at the cumulative number of new digital product codes. This is that novel type of innovation. That's going up over time. If anything, there's a lot of action in cardiovascular devices, which is the solid navy blue line. We can look at the cumulative number of digitized, previously analog product codes. So this is this like digitizing an analog thing, also going up and to the right over time. We can look at the cumulative number of product codes with follow-on digital devices. These are the 4 different flavors I told you about of new product commercialization, going up over time. And then these are the updated digital devices. This sort of mechanically only has to go up over time, but it is. So these are, again, this is when a firm that already has a digital device in a specific product code comes up with another one. So all of these and the axes are different in all of these. So we're going to run some quick regressions. I'm looking at the time. I'm going to skip over this. I'll get to the conclusions. I definitely won't bore you with this table, which is far too small. You'll see. I'll get to this in a minute. I just want to say one just quick word about ongoing work and next steps. Something that we haven't done yet is actually look at how these things change over time. The graphs I just showed you look pretty smooth, but we have some reasons to believe that if you run some of these regressions on different subsets of years, the coefficients change a little bit. I want to understand that a bit better. I can't tell you much about it now, but thinking about what's going on over time, in particular what's going on in the context of the introduction of artificial intelligence and machine learning devices, do the innovation profiles for these products differ from, quote unquote, regular digital devices? Digitization, of course, is a necessary but not sufficient condition for artificial intelligence and machine learning. This graph is figure 2 from Chapter 4 of the NBR volume on the economics of artificial intelligence in healthcare, which came out in March, where this top line is just a version of the pictures I just showed you, which is the share of software devices. The bottom line, which is on a different axis, and this is important, is the number, or not the share, sorry, the number of software devices, and the yellow line is the number of AI devices. Which looks much more like the pictures Karim showed you earlier. And I think there's a question, maybe Iain, you have some thoughts on like how can we kind of incorporate things like this? Is this an instrument for something? Next steps. So in summary, I have 2 minutes, right? I'm doing okay. This is my last slide. We see significant growth in digital medical devices with a lot of heterogeneity across medical specialties. I think there's more to do there. We have this method for using off-the-shelf document classification tools to analyze the contents of new product descriptions. Resources matter for commercializing novel digital products. Both publicly traded firms and those with more VC funding are more likely to innovate. But access to capital doesn't seem to matter for all of these different flavors of follow-on innovation. Experience in developing similar products, both clinically similar, so again within the same medical specialty area, or software-driven products is associated with a greater likelihood of digitizing analog product lines, but not with developing novel digital devices. And so, as I said earlier, the digital transformation, if we can call it that, of the medical device industry does really seem to be creating different types of opportunities for different types of players. And I welcome any thoughts on what we should do next. This is still work in progress. I think I saved us a minute. So now we're only 9 minutes behind.
Yes, that's right. And in 5 seconds you should get your final minute ring, but we can proceed and hear the speaker. Thank you.
Well, it's a pleasure to read and think about this paper, as it invariably is with Ariel's papers. Don't want to rehearse word for word the principal findings, but let me just offer some observations on what I think is learnable here and why we care. First point I think is that medical devices is a grossly neglected and understudied part of the innovation economy. Ariel's one of the few people working on it. It's a couple of $100 billion a year in the United States. Put that in context, pharmaceuticals is, maybe 700 billion. It's very large. It has these kind of interesting, distinctive features which make it, I think, a useful place to go testing and thinking about our ideas about how we think the innovation sector works. Somewhat like the pharmaceutical business, market access is largely controlled by a safety regulator. Unlike pharmaceuticals, it's an area where there's this kind of rapid and continuous incremental innovation. It looks a lot more like ICT in Silicon Valley in that respect. It's also an industry where there's an interesting and different cast of players, including but not limited to, I think it's approximately true that every single orthopedic surgeon has their own little stainless steel thing they want to drill into your spine. There's a lot of artisanal physician-level inventors working on this, and they think they go surprisingly far up the hierarchy of complex and expensive devices. So that's all kind of interesting and different. This is a very Grilichesian paper. As I say that, I'm reminded of the years I spent sitting in a carrel outside Zvi's office, where there was a parade of people coming in with every possible mispronunciation of his name. I think they'd all come and knock on the door and say things, Professor Grilled Cheese. That was my favorite, grilled cheese, but Griliches, grilled, at the end of which you'd always, in the course of this discussion, I couldn't help overhearing there'd be a comment of, well, I think you got some problems with this data. So this is a very Grilichesian paper in the sense that it's involves some heroic data collection. I'm reminded of what Jim Heckman was saying yesterday about administrative data sets. They're large, they're comprehensive, they're very interesting, they're often difficult to deal with. So hats off to what the authors of this paper have done in digging into all of this public data, which is actually, there's a substantial barrier to entry to getting into it and understanding it and linking it out. There is, I think, here a very useful distinction drawn between adding digital capabilities or add-on functionality to existing products, versus doing something which is completely new and is of its essence something digital. Here's my set of pictures of medical devices. The one at the top left there is an implantable pacemaker. Interestingly enough, those have been around since the late 60s, and in them they have a computer. In the late 60s, it was kind of an analog computer, but what it does is monitor what's going on in terms of electrical activity, and if it looks like you're going into atrial fibrillation, then you draw some power from its battery and zaps your heart and tries to get it going again. The current state of the art obviously does not, there's not a little tiny circuit board with, valves on it, like transistors. It's entirely a little computer sitting in there, hopefully running the Linux operating system and not, Windows. But the top right is where I think the state of the art is here now. Here's the dreaded spot on the scan, which has been found by a machine. For many years, they used to track digitization by asking my MBA class, if you call an Uber and it arrives and there's no driver, are you willing to get into it? So 8 or 10 years ago, the answer was about 10%. Now it's over 50, but let's get some audience participation in the after lunch session. Hands up, if you would be perfectly happy, you felt a bump, and the doctor came back and said, well, the machine says it's X, and now I'm going to prescribe you drug Y. Who's willing to take the machine with no human radiologist? 20%? Yeah. Then there are these things, you know, the continuous glucose monitor. And then lastly, and this is the really interesting thing, this is supposed to be a picture of a clinical decision support software where AI and algorithms are going to try to force the physician's hands in how they're going to diagnose or treat you. Each of these, I think, are different and interesting classes of progress in this area. So I have a few questions and suggestions here. Let's start with this question of can you identify the descriptions of new devices as being digital and in what respect? I'm sure there's not many false positives from the approach that the authors have taken here, even though, as I understand it from the paper, they're using a pretty restrictive set of keywords. The false negatives, I'm not quite so comfortable with. So I have a couple of suggestions here, one of which is the FDA has published this list of 882 AI machine learning medical devices, and that would be a good validation exercise to see what your rate of false positives and negatives is against that. You could also think about extending the set of keywords by going to things like abstracts of related patents and so forth. Where I'm a bit worried about the validity of this approach is in thinking about changes over time. Spare a thought for the regulator here. Back to that cardiac pacemaker, it's kind of like the problems you have with control software for the Boeing 737, right? There's an algorithm in there, it's running, you can try to validate the software. If it goes wrong, it's going to go very badly wrong. And so the FDA, since the arrival of more and more of these digitally based devices, has been really struggling to come up with a regulatory framework. So that suggests to me that there's the possibility for some unevenness over time, and particularly depending on the categorization and the amount of FDA wrangling, there's a clear incentive for some device, for some of the applicants in this process to try to, weave and dodge and try to find their way through this regulatory system. I don't think this is likely a big problem, but it's something I'd want at least to think about. Another thing I think it could usefully do here with these data, now that the FDA and other international equivalents is starting to try to draw a hard distinction between software in a medical device, so that's like the pacemaker example, or CT scanners doing computerized tomography, versus software as a medical device, which are the AI clinical decision tools and so forth. I think splitting the data that way might be helpful. The paper starts, after combing through this data, it goes through some interesting initial observations about how they might think about I/O and competition in this industry. I'm not too surprised that you don't find much truly novel digital stuff coming from new firms, because the problem is that the incumbents have a lot of intellectual property, right? Pacemakers have a couple of thousand patents covering them, right? So it's going to be very hard to, I want to take Dietmar's exciting new device, I'm going to add another feature on it, because if Dietmar doesn't license me, I can't get into the market, so I'm not even going to try. I'm also a little concerned here about how to think about the demand side here. This is not the place to worry about it in depth, but the healthcare sector has been steadily 25 years behind the times compared to the rest of the economy in uptake of digital anything for a lot of complicated reasons. I wonder whether that impacts incentives for innovators to think about getting into this.
A minute.
1 minute. Unfortunately, sales data are hard to find and very expensive. It would be great if you could do things like reweight the findings based upon, is it a Mickey Mouse little thing that never got anywhere versus something exciting. We can't do that. I'll wind up here by making the observation that I think there's at least 2 and possibly 3 papers inside the one that Ariel sent me to read. One I think is a measurement paper, which I think is important and really useful, and there's clearly further avenues to go there. The other is this kind of incumbent entrant. What's the nature of competition? What's the role of incremental versus radical innovation there? And thirdly, Ariel didn't emphasize it, but there's this angle about what's it got to do with geography. So I encourage the authors to keep working, and I look forward to reading all three of those papers as they emerge. Thank you.
Thank you. Great. We have time for questions and comments, but first a response from
Yeah, thank you.
Ariel.
I learned my lesson this morning. If you're discussing a paper, have to get up again. Don't sit like smack dab in the middle of the row. So I made it up quickly this time. So Iain, absolutely, this is wonderful, and I was delighted that you were going to be discussing this paper, because I think you also are one of the few people who knows about the medical device industry vis-a-vis things like pharma, and I think that there are some good but also some very bad analogies that get made in innovation research in that setting. In short, so I agree with sort of the excitement around studying the medical device industry. I think the false negatives point is really important. I think the only thing I want to say before we open up for questions is there are always measurement challenges when you're trying to come up with new measures, and so I welcome, perhaps not now, but in the next coffee break, any suggestions about things very much in the spirit of what you suggested. I think we're doing some work. We're actually using a new database and trying to kick the tires a bit around what we're actually measuring. I think there's an argument to your point about sort of drift over time of actually, like, what if we just focus on the last decade? Because 20 years of data sounds really cool and sexy until you realize that, like, people talked about things differently in 2003 versus 2023. So I agree completely. In fact, we're seeing glimmers of that already. So you've nailed something that you didn't know I already believe is a weakness of the data set. So and the sort of split of software in versus as a medical device, I think, is increasingly important. And that's a great suggestion. We'll do that. So that's all. Shane has a mic already.
Yeah, great.